Good evening, everybody. Happy Monday. This is going to be a relatively rare one-off stream for me. But if there's interest, I will kind of keep these ad hoc. I'll try to let people know probably day before, and we'll do some tutorials. So this one it's one I've been meaning to do for a bit, and there's a lot of interest around scraping. That's going to be the topic for today, is we're going to be talking about web scraping from a list of examples. I basically volunteer on a community called rvest, which is a Slack community that's centered around R, and kind of stumbled on this example of kind of an average question that somebody might have, which is, how do you scrape something from a website? And I wrote out an answer. I won't look at that answer right now, but the idea was, how do you think about scraping a website? What kind of instincts do you have? I've scraped a bunch of websites in my time. I probably will continue to scrape many websites, but the idea here is I want to get to the point where I want to kind of explain my thought process as I scrape stuff. Everyone kind of starts with this. They've read tutorials, but I think it's really useful to kind of build up the familiarity with tools that are available at your disposal as you kind of work through these things. So we'll start with this example. As I mentioned, hey, this would be a good candidate for video scraping. As I work through this, I kind of gathered up a bunch of other examples. So we'll work through a few different tools that I like to use when scraping websites. But we'll start with, and I'll share the gist of various examples that I want to tackle today. I'll share that in the chat here. But the idea here is, here's a list of things I want to tackle. I'll make a repo of this and put it somewhere, including the code and a YouTube video when that gets uploaded. But today we're going to work through kind of a bunch of questions I've kind of gathered over time. If you have any questions, please feel free to stop me, ask me questions, ask me to go over something again. So I normally don't stream tutorials, so I normally very. Hello, are we back? I feel like we're back. Twitch seems to think we're back. Sorry about that. Anyways, like I said, we'll get started. We're gonna get started with some scraping. So basically, this is the gist of the reprex. I'm gonna look at it from this code only, and then we'll try to work from here into kind of what I my thought process as I work through. Yeah, you can submit me new things to scrape. I'll put it on the backlog after this. But feel free to actually what might be easiest is if you drop a comment onto this gist, and I will try to get to it after. I'll be here for 2 hours. More or less. There should be our streamers or data streamers after that, which we can raid after. But I blocked out 2 hours of my time, and I will basically try to scrape everything. So, in that 2 hours, I'll scrape as much as I can, and I'll save all that code so you guys can go back and look at it. I'll make gist is pronounced the same way you pronounce GIF. Actually, it's pronounced the opposite way. So if you pronounce gist or gist or gif or gif, whichever one you do the opposite for this one. No, actually, Jesse doesn't stream till. The idea was I looked at Jesse's timeline, okay, I'll stream 2 hours. I'll stream towards Jesse's stream, and then we'll go raid her after. So that was my plan. I'm gonna make a quick command here. And the goal will be you can just add stuff for me to scrape if I get time to do it. I will do my best. Okay, so there's a new command called scrape this. Oh wait, scrape has the word crap in it. That's not good. Stream or add to list. We'll call something like that. And then go, actually wait, never mind. I could just go with scrape this. Okay. Okay, so the command, if you're looking to add stuff to my scrape list, is scrape this. And it will go to this gist page here, and feel free to just add stuff to the comments below. So we'll start with kind of the original question that spurred me to this, and the one that, yeah, that's also not good. But, you know, we'll just roll with it. Okay, so this is something about mines in Limpopo. So I realized, as I set the time, that he probably wouldn't be awake to watch this. So this is recorded, so I'll make sure it goes on to, well, it'll get recorded in my VODs and on YouTube afterwards. But you can kind of see what he's trying to get at, which is, you know, there's a bunch of mines here. This is actually really annoying. How do I get rid of you? No idea. Okay, so the idea here is that there's a bunch of mines and they have a bunch of data here. And how do you scrape all of this stuff, right? Seems pretty consistent, goes all the way through to here. So, you know, we're going to try to get all of these data points. So set up an R script. Tidyverse. I will maybe go a little bigger there. Okay. And library rvest. Those are probably like 90% of what you're gonna need. Thank you for the follow. Trevin, welcome. And we'll start with the code that he put out because you know, when you have a reprex, let's look at it, right? So we'll copy this into here. I don't need the comments. Okay, so we're looking at this page. There's an accordion here. So I think, so that's what this web structure, like this page structure is called an accordion. Basically the idea is if you click this and then you click that, the other one, like it kind of all folds together. So we're going to try to scrape all of this stuff. So we'll see where he got to. And the way it's done, so he's got the call MD, etc. And basically what happened here is you've got just the call MD6. So if you're going to look at these and you right click inspect, I like inspect actually better than CSS selector gadget. I know gadget's like convenient, but I think it's worthwhile to I will first of all make this bigger. I think it's worthwhile to kind of inspect the page structure, because if you are inspecting this page structure, it usually gives you a better idea of what to scrape. One of my favorite resources for this, and I still refer to this all the time, is Julia Evans' CSS selectors. I will try to find that link, and A, I'll save it here somewhere, and B, drop it in chat. So chat. And okay, this is seemingly very, very annoying, so I will do my best to, but please feel free to drop it in the chat. I do have it open, so the moment it dies like that, I do like get a note, so feel free to say something. In the meantime, I will figure out what else is killing my consumption here. And we'll try to pare down our compute usage to make sure that I stay up. Okay, so like I said, we're talking about this stuff. I'm browsing through it in the CSS selectors here, and as you kind of hover over these, you can kind of see what I'm looking at here. So all of these rows have this call MD6, which is columns, I think, and what the code that was previously written does is it accesses these and then converts it to text. So that's where you get this text mostly. I'm online, right? Yeah. You guys are still here? Yes. Hello. Okay. So not bad, but we can do better, I think. if I want this, I want to know not just what the details are, but I also want to know what the mine that comes from, what mine it comes from. So not just this, not just the text that's within this code here, not just the text that's inside here. We also want the text that's that comes from this. So one of the ways that I like to do this is to kind of set up like a branch point. So I just pare down as much of the data as possible, pare down as much of the HTML as possible, and then we'll get to a point where I can start stripping things from it. So if we kind of go all the way down to this call MD6 class, that's inside here, which means we don't have access to any of this stuff. So we're going to try to find an access point that's slightly before that, and kind of we'll just use this we'll use this browser to kind of find that. And I think accordion's a good spot, because then we can start accessing stuff within this. So we've got a bunch of panels inside there, which have a heading and an accordion body. We're not that interested in the actual components of the body. We're interested in this call MD6, and we're interested in this panel heading. And there's actually, it's called, like the best one here is a panel title. So what we can do is kind of set up a branch point. Here. Okay. And then we're going to take the accordion selector. So the accordion, remember, from the comic, is it takes the selector, right? So it takes the ID of the accordion. So we're going to take this accordion, and we'll take this ID. And so to refer to IDs, you do a pound sign, hashtag, and then accordion. And then we'll stop here. So we're going to call this, we'll call this accordion. Why not? Okay. So basically, to check that it works, what you want to do is just make sure that it's a list of 2 with a node, blah, blah, blah. Like, if it has something here, you've got something. Sometimes if you mess up this, it will return a list of null, which is bad. List of 0 is bad. That means there's nothing in there for you to get. If there's a list of usually 2, sometimes more, you've got something, and you want to look at this stuff, right? So, we're going to try to, we set up that branch point here, and basically what I like to do from here is just put it into a tibble right away. HTML text 2. So HTML text 2, I didn't write this code. I grabbed this from his reprex. HTML text 2 removes a bunch of stuff, so we'll look at that in a second as well. Okay, so first things first, let's get the panel headings. So we'll call it headings. This is actually probably mines, but we'll go with that. And basically, we'll start with the accordion, and we'll do an element select. So select element takes the first element. Select elements takes all the elements that match that selector. So it's kind of like taking all of them versus taking like just the first one that it finds. So in this case, we could have done HTML element accordion because it would still just return the one accordion. But if there's multiple accordions, it would have only taken the first one. HTML element here, and this is the latest version of rvest. In previous ones, you would have done HTML node. They do the same thing. So I could use node here or HTML element. I'll use element because it matches more closely to my mental model. Okay, so we want the panel title. And what we want is the text from that. So here we're going to take the class. So remember, jumping back to the CSS selectors, classes can be taken by taking the class name and adding a dot in front of it. So that matches this. So we're going to take this class that is panel title, and we're going to go here and go HTML panel dash title, and we want all of the elements that do that. So we want HTML elements with the class panel title. I like to just hover over this and then run it, and it's just, you can see it returned you a whole bunch of titles, and there's 148 of them. If you wanted to manually verify that, you'll get a list of titles. But from here, Tony asks why HTML text 2. We'll start with HTML text, and we'll show you what happens with HTML text. In this case, nothing. So you could just use HTML text. HTML text 2 does a really good job of stripping out like line breaks, white spaces, etc. And it's actually useful, I think, in the next one. So we'll go there next. But basically what we have now is a data frame of all the mines. So this is all the panel headings here. And then what we want next is all the stuff inside of it. So because we set this breakpoint, we can still refer to accordion here. And we'll call this data. And accordion, we're going to take all the elements. This time we'll just reuse the I think it was call MD6, and that basically the idea here is we just want to get, and always feel free when you're looking at any element to right click on whatever it is exactly that you want. So if you want this text, fine. If you want this text, it's a different selector. So where you right click matters, and then just press inspect again. This is Firefox, by the way. It's my favorite of all the browsers in terms of dev tools, as well as just security, not Google, blah, blah, blah. But I think it does a really good job of having a really good developer tools suite. So what we want is this call MD6, which is what I think selector gadget would have returned. So we're going to call MD6, and you can kind of see what happens here is you get a list of 1480, which is a lot of stuff, right? So what I want to do instead is, so basically this gives you a list, and then if you do HTML text on it, you'll get a list of 1480, but there's no way to match that to the well, I guess you could divide it by 10. But so did you see so when you asked about HTML text, like regular HTML text, this is what happens. This is what you get out of it. There's like, and there's a bunch of breaks, there's postal, and then there's more breaks. And so basically this is your whole value. If you do HTML text 2, it strips out all this stuff. And so you just get the character stuff that you want, as if you were kind of printing it in a browser or what have you. Okay, so if we were kind of looking at the data here, you know, that's it, right? Like if it was simple, we would be done. But we don't have matching line lengths, so you get, you know, 1480 column data, 148. So this works, except you need to kind of repeat mines 10 times each in order for it to match the same length of 1480, which is fine, except what happens if it's jagged and one of these lines are missing? Well, then your repeat function won't work. So what you could do instead is kind of turn this into a map where instead of taking all the elements that are in accordion that match this, you can do one for each element of the panel groups, I think. Hang on, let me see here. So you have a bunch of panels. So you have SC element, you have panel default, you have panel heading, and then you have a bunch of accordion bodies with a panel body class. So if you take the panel body class instead, and you just grab this. Wait. Too many pipes. You just take this instead. You still end up with a list of 148, and then within each one, there are call MD6s. So this is cool because what you can do is instead of just mapping, instead of just continuing down the selector path, you can actually use it in a map. And what that would do is do this function for each element that's inside panel body. So for each element in this list of 148, do this thing. So when you do here, you take this, we'll use .x to refer to the previous, like the list element that's passed in. Hello, Matty Two Shoes, welcome. We are scraping stuff. I'll start some indenting here because it's getting a little hard to read. Okay, so we're gonna take all the elements inside of that list element of panel body and map it so we only want col MD6, and then we'll convert it to HTML text 2. And what that's gonna do is it'll give us a list of character vectors that are 148 long and have all the contents inside. If there's 10, great. If there's 9, doesn't matter, right? Like, it doesn't matter what's inside as long as it's there. So we're doing that HTML text, and for each element of that, each panel that's there, just give me all the col MD6s as opposed to all the col MD6s as opposed to just giving, instead of just getting all the col MD6s in a list of 1480, because sometimes it's 1479 and then you're stuck, right? So you don't know which one's missing a thing. Now it's there. Thanks to the raid, Matty Two Shoes. Welcome, welcome, welcome. We are working on web scraping. This is a bit of a tutorial on scraping in R with rvest. Okay, so now when you do this, you'll see that we've got a full-on tibble with a list of character vectors inside, which is much easier to work with than a list of like one column that's 148 and the other column is 1480, right? So that makes it easier for us to scrape through these and kind of deal with this vector. So we can view this. So instead of looking at it in the console, we can look at it in RStudio's editor, and you can kind of see there's a whole bunch of stuff in here, right? Well, the thing you can do with nested data is unnest it, right? Nested lists, unnest, yeah, they go together. So we're going to unnest. This is, what did I call this? Data. And that gives us that list of 1480, but now we're repeating the mines, so that heading, n number of times. And for every element that's in there, we're going to repeat it so it looks like a proper table. And I'm going to actually assign this, we'll call it mines. And so now we've got a data column, right? So, you know, we've got this data column, so now we can start taking like tidyverse cleaning to it. So you see that it's got a semicolon here, or it's got a colon here, so it's separating the field by colon. So what you can do is separate this. We're going to take data, let's go to the field, and we're going to separate it into mines, or sorry, name and value. We'll make sure we stick with lowercase here, and we'll use that colon as a separator. So sep equals colon. Anything else? That should work. Okay. So now instead of the previous thing we had, actually I think there's a space here, so we can go back, add a space to that separator, and that'll kind of clean that text a bit for us. Okay, so now we've got a name and a value. And to get it back to tidy data, where, you know, every observation, which is a mine in this case, has a field, all you need to do is stick this into a pivot wider. So we're going to pivot wider, names from names. We're going to take name. This is for Ben, who still needs to love pivots a little bit more. We're going to take the name, and we're going to make those go horizontally. We'll take the value and use those as values. So names from name, values from value, and bang. You got one mine. You got a mine code, mine name, commodity, type, owner, telephone, district, etc., etc., etc. So all in all, that's all it needs to do. So from my end, that's done. You get this thing, but you get it in a data frame, and then from there you can keep extending stuff. You know, I think you mentioned something about separating rows here, so you get commodities into its own rows. So if you're looking at the commodities itself, you can use separate rows to split this quickly into something like, what do you say, commodity and then you get, instead of having one mine for everything, you get, you know, the commodity, and then those commodities get split out over, you know, however, like whatever kind of commodity it has, and then you can group by the commodity and deal with it from there. Anyways, I'm going to leave this code here because I think that's tidy in my mind in terms of observations for every mine. And then, you know, we can kind of leave it from there. So we'll save this. Okay. So any questions about all that? Because I've got 4 other things. I've got 90 more minutes. We'll cross our fingers that technical difficulties don't persist. And we've got more to scrape. I don't know if there's more stuff in the scraping pipeline. We can check. But if not, we'll move on to scraping this page. So this is a bit more classical in my domain. Sports, even though it's basketball. And Anthony Amico kind of posted this question in some, I think, a Slack that I'm in. And basically what we want from this page is this is a data frame of NCAA players from 2012-2013, and what we want to do is get all of these links. He's on an NBA draft betting binge. Cool. I think I peripherally knew that, but I've been really like, I have had my head in the sand with FF Simulator, which I submitted to CRAN on Saturday. So hopefully that gets passed through very quickly. And kind of coming out of that right now. Okay, so we're going to try to scrape this. So again, we use the same process. I will restart R. I will start a new script for it. Here. And then this is realgm URL. Save this. There. Okay. Alright, so we want this page. Again, we can do the same process. Start with the inspect. Look at this and say, okay, so right away, when I click really deep in here, we're on this table saw class. Table saw is probably some kind of package that they use to build this table. But it doesn't. So we'll start with table, and So we've got table. So let's cross our fingers that we can just grab the first table, and hopefully we'll only get one thing. So we'll start with URL. We'll pipe it to read HTML, and then we'll pipe that to HTML element. And this is going to be, we're going to look for tables. This is not I don't think this is an ID. So there's a bunch of IDs here. But what I want to do is just grab like the HTML selector table. So that doesn't even need so this matches the table element here. So we can just, there's no prefixing required. You just grab table. So there's a list of 2. Sorry, so I used HTML element here, and I just took the first table. So I'm hoping that this is the right table. Sometimes pages have 2 or more tables, which can get a little fussy. So from there, what you would do is figure out how to select that table that you want specifically. In this case, we're lucky. There's just the one table. Yeah. So I ran elements to get all of them. See that there's only a list of 1 table. So we'll go back to the regular element here. And like the naive way to do it, not the naive way, the crash it into whatever so that hoping it works is just run HTML table. So you get this HTML table, and you notice there's no links. You just get the raw text that's here, which is exactly what it says on the tin. It just converts your table structure into text. But what we want is a URL from here. So what we should do is set up that branch point again. So we'll keep it as nodes. We'll rename this node actually, and we'll call this realgm table. And node. So this will give us the same result. We'll keep it there. So we know that there's 224 observations of 9 variables. you know, we've got stuff here. I could use janitor clean names on it if I wanted to. It's not that important at the moment. So, okay, so what we want to go with this is trying to get through the links. And Anthony specified that he doesn't care about any of the other links. He doesn't care which university they went to. He doesn't care about any of that. He doesn't care about the birthdays. He wants to know what's the player's link themselves, which we can get, right? So if we right click this and we inspect it again, we're taken straight here. So inside this table, there's no class that specifies the player themselves. So there's a couple approaches to this. And my favorite approach, so basically, hang on, let me kind of go through here. So there's 449 nodes. How many nodes did we get? 224. There's 224 players. I don't know about this 449 node thing. But what we want to do is kind of look through these and say, okay, so thanks for the follow, 4cat. 4fcat. Nice. Okay, so we want this table, and there's no, you can kind of see there's no real way to determine that it's the player column. So sometimes some sites have columns, right? And they class their columns differently. This one doesn't give us that. What it does give us is this href with player and then Jordan Aberg summary, blah blah blah. So going back to our handy dandy list of CSS selectors, we can see that we can select all the A elements with an href attribute starting with HTTP. So the cleanest way to get a vector of all the URLs is to actually just write this look ahead thing. So we'll say player links is going to be a tibble. I like to go into a tibble because I think it's the easiest way to do stuff. So this is going to be a URL of real GM node, and what we're going to do is write this selector. So HTML element, so we want all the elements that match this. It's going to be an A with square bracket href, and really what I'm doing is just copying this here. Href circumflex. I don't know what that's called in American. That's how I pronounce it in French, English, Canadian thing. And single quotes, player. I think it's slash player. Apostrophe, square bracket, and then that's there. And we can just hover over this text and see what it brings us, which is all of these nodes with this A and this starting with href. So this is very useful because what we can do is then do HTML attribute and give us all of the hrefs from this page. So from these nodes, give us all the hrefs, and bam, you got a list of players or their URLs. This is only part of the URL, but you know, I think this is good enough, and I think he wanted IDs, so I think we're going for this part, but we'll keep the whole URL, and from here you can just bind the columns, and now you have a table with all the same stuff as before and their URL. This is a lot of what kind of code would be behind my FF Pros package for Fantasy Pros. I do a lot of the same kind of stuff here. So you just kind of attach this here, and you know, you can do stuff with this, like, you know, browse or map over all of these URLs, grab this ID, which is I think the player ID, etc. going forward, right? So that is where I wanted to get to with this page. Any questions about that? Drink. My stream hasn't died, has it? Even better, Canadian too. Yes, I am very proudly Canadian and rather embarrassedly from Ottawa. So kind of like that, like Ottawa, like Sens fan thing. Black. How do I get that HTML element? Yeah. So if you, I want this selector. So from this comic, Zine, I should call it. I want this, give me all the A, so that's a link element, or anchor element, that starts with href. So href meaning the URL that this link will go to. Give me all the ones that start with, and then you could refer to your page and say, okay, so I want the ones that start with player. And then that will give you all of the A elements with an href attribute starting with player. You know, I think makes sense. RStudio makes SQL databases. RStudio, the company, and RStudio, the IDE, do not make SQL databases. You can interface with other SQL databases from there, or you can use you can interface with databases directly with it, but you cannot. Well, you can. Everything is possible, but in this case, well, the short answer is no. It doesn't. They don't make a SQL database product. I think that's probably the nicest answer. Yeah. Okay. So if there are no other questions about this particular page, we'll move on to something a little more interesting. So surprise, surprise, I am also on Reddit, and actually got started in coding and Dynasty Fantasy Football on Reddit, by the way. Fun facts. Okay, so I'm trying to scrape track and field results from this TFRRS system for a stats project using rvest. It can't access any other year other than 2021 because that's the only data displayed by the link. TFRRS.org results search. You can filter by year within the web page, but it doesn't change the URL. So I don't know how to look at the other years from the data within R, new to web scraping. What's the right terms to describe this issue? Basic code to get stuff from each of the 21 pages of meets for 2021. Okay, so let's visit this page. Okay, so we got this page, and as promised, when you change things, it doesn't update the URL. So right away, this could be a barrier to stopping you from scraping stuff, right? Like, you know, how do I get beyond what the page gives me when I go here? So hang on, I should save this. Scraping realgm.r. Okay, so start a new thing. I am very extremely online. Am I going to pull out Selenium? Actually, no. This can't be done without Selenium. It involves a little bit of web snooping. We'll call this TF. We'll call this track. I won't remember how to the abbreviation properly. Okay, not that. I don't want to copy that. I want to copy this thing. Bing. Okay. So we got. Whoa. Wait. We always restart R. I restart R more than every other R streamer I've ever met. Restart R all the time, folks. It solves like most of your problems. Okay, so you got this URL, and we're gonna read HTML, and we're gonna go HTML table just to validate that yes, you get 1,000. I should try turning it off and on again. I restart R like constantly. Okay, so there's some stuff here. So we'll get to just the table element, table pipe, and look at this. Okay, so as you can see, there are 5 pages of this data. The earliest one starts Harding Spring. Wait, no, that's not true. Yeah, but Tony, you don't stream. I said our streamers. I'm attacking 2 people at once. It's great. Love it. Okay, so the very first one is the Centennial Conference outdoor track and field. So if we kind of scroll all the way to the bottom, we can kind of see if we got it. We did not get it. Alienating my chat. I gotta smack talk him a little bit. Apologize. I don't know. Is it? I mean, just being Canadian apologizes enough for me. Okay. Anyways, it looks like these are out of order? I don't know. Let's look. Let's make sure we got that thing. I think. Yeah. Okay. So we did get this. It just sorts funny, and I think it's because it starts with a 5 and 5 1 5 2. So this sorts in a different order. But it is here. So we did get all of the results from these pages, but we can't get to 2020, right? So what we want to do is okay, so what we want to do is go back to our handy dandy inspector. We know this is a table, so I won't go into like, you know, panel body, which has a table in it. Well, we already talked about that, right? So the part that is the really interesting part here is the network tab. And with network tab, what you're doing is snooping on the request that the browser itself makes to display that page. Sometimes it's running a query backend. Sometimes it's running JavaScript. Anything that's not loaded with the page has to arrive there somehow. Every page is like this. Fantasy Pros, you know, can load stuff backend with JavaScript. In this case, I think it's doing something similar. I don't remember exactly, but what we can do is run Control F5 with this tab open and resend. Okay, so you're seeing a bunch of, this is all the stuff that they load when they go here. So what we've got is a whole bunch of JavaScript. Most of the time, the JavaScript isn't what you're looking for. Sometimes it is, but most of the time it's not what you're looking for. Because, you know, this just, like, JavaScript is like, it does stuff. Most of the time you don't return data in JavaScript. Most of the time you return, like, functions. So it's like returns a bunch of various R packages, for example, that is required to display the page. And then the page itself will figure out how to execute all that stuff for you. So it's not usually images, it's not usually the script, style sheets, or script here. Style sheets are CSS. CSS does not contain content, it contains prettiness or ugliness depending on the site. Okay, so the interesting part here is this post. So what we're seeing here is that instead of a GET request, which is just take this stuff from here, post is the browser decided to send something to their server and then received something in response. So this is probably like 99% now that I'm re-looking at this again, the reason why, this is the reason why A, you don't see the data, like the URL change, because it's not actually visiting a different URL, and B, this is probably like 99% the reason why you're getting, like, this is the reason why the data is being populated. This is the reason how, like, the method that the data is being populated. I realize that I am in front of the important parts here, so I will shrink this over this way. Okay, so we saw that we were putting in 2020. There's a bunch of cookies here, and it could be one of these cookies that, you know, you may need cookies, so you may need to deal with the cookies when you're doing a post request. So it doesn't look there's. So sorry, I said there may be cookies. It doesn't look like it yet, but we may need them. There's a bunch of requests, so you can see that it's sending a bunch of stuff to the server, specifically the year 2020. So, you know, we just received 2021, but we didn't receive 2020. So what we probably need to do is post all of this stuff to the server and hope that it sends back the same stuff that it did here, which is more of this stuff. But see, it's sending back 2020 stuff now. So this also needs to be parsed pretty much the same way as the 2021 data, because it's sending back HTML. Sometimes when you post stuff, it sends back JSON, in which case you need to parse it like JSON. In this case, it's sending back HTML, so you need to parse the HTML. So let's form up a post request. So to do post requests, sorry, that would have bothered me for ages. Okay, so we got this URL. So I think this is the exact same URL. So https tfrrs.org result search HTML. So I think that's exactly the same. And we're going to post stuff to it instead of getting stuff from it. So rvest backend runs a GET request. It doesn't do any post that I know of. I always just default to HTTR to do this. Basically, to do a post request, you type post and you put this URL. So if we refactor this, we can use the URL that I put here. If you just run a blank post request, it will give you back a bunch of statuses. In this case, you're looking at this status code 200 and saying, okay, so it returns stuff. So if you run content on this, content's an HTTR function. I could prefix it so that you guys get familiar with this. You get this HTML as if it was here, and then you get back this 2021 data, right? So without any parameters, it's running this post backend and saying, okay, so I don't know what you want, so I'll just give you the default, which is this year's data. But we don't want that. We want the 2020 data. So the easiest way to do this is to add some parameters to give this post a body. So comma tab gives me the autocomplete. I like to make sure that I'm not messing up the typing. So we do body. We'll type list here. Okay, so when you do a form request like this, basically your goal is to match exactly what's happening here with what, like, this is what they sent, so this is what you want to send. So that way. There. Okay, so meet name equals blank. Blank meaning like single, like quote quote. My Slack is going off. Bye Slack. Sport equals track :XC. State equals blank. Month equals blank. Year equals 2020. In this case, it's got quotations, so just put the quotations in with it. And wait. There. Now we've got 2020 data. So with this in mind, we can grab all of this data. So this is 2020. We spoofed the data so that now we're getting the 2020 data instead of 2021. You can see there's 935, so I think there were 1,000 last time. Can't remember exactly. But this gives you all of the data that was here. And, you know, we can do similar stuff like grab the URLs, again, which, you know, if we write a function to get this URL, we can. Hey, it's that table saw package again. I wonder if this is popular for whatever backend, PHP or something that's powering this. So again, get the href, get all the A elements, get the href, slap it on. There's your thing. So we can grab a quick function, and the goal, so my end goal will be grabbing all of the available data from 2021 to 2009. And let's do that. So we'll set up a function to scrape because we want to be able to pass in this year. So we'll set up a function year. Actually, we'll call this season so that it delineates from this year. And just leave that there for a second. Okay, so we'll hard code this result search in here so that we're not referring to anything that's outside of this. And again, we'll set up a branch point. I'll call this track page. We'll change this reference in a second, but I want to grab this URL first, so we can reuse this idea. Save us some typing in case there's more scraping that I need to do later. These are meet links. Take track page. We'll take anything with an A, href, HTTPS, I think. Actually, to be honest, it's probably just all the A links now that I look at it, because there's no other links to these things. So give me all the A elements and give me the href elements of that. So you get meet links. There's 935 observations of one variable. Okay, so that gives us a track table. This looks terrible. What is going on? Okay, this needs some janitor. So the part that I said, so I said this looks terrible. These columns look, I have no idea what's going on here. So we're just gonna run janitor on it. Clean names. Okay, so the distinction here doesn't really matter to me, but that's our function. So after you do that, move all this down and return track table. Indent all this stuff. Okay, so that's our function. We made a function called scrape track. We didn't actually insert the season yet, so let's do that by putting it here. And then basically what we should get is scrape track 2021. Hopefully that returns our data frame. So this returns the 2021 data. So we want to map over all the years that we want. In this case, 2009 to 2021. We're going to map DFR that so that we bind all the rows together. Okay, so we're going to run that over all 11 pages. It takes a minute. Okay, so you've got 12,000 observations. Which makes sense. I think this is every track meet in all of the US. Over 10 years? That sounds about right. So we got data going back to 2009 and all the URLs and all this stuff. There's more cleaning to do here. So I see that there's this format of dates, which is kind of ugly. I won't deal with that today because we're going to focus on scraping stuff. But, I think that all seems to work and we've got a bunch of data frames. Any questions about that? That seems to make sense. Good, yes, good, no, yes. Anyone still here? Did my stream die? I keep checking if my stream died because I don't normally check, but I don't know, 4 times it fell down, so I'll kind of just roll with that. Make sense? Alright. This code will go onto probably an office hours repo, and I'll link it and the YouTube or Twitch VOD. So you guys can, try this out for yourself. In the meantime, we've got one more in the preset examples. So I will go through that. I collected this one off of Twitter from Not sure what the person's Twitch name is. I've seen them on here, but I am not sure. Nope. Okay. So, Star Trek LT wanted to know if I could scrape the G.I. Joe action figures here and get all of these pages onto a thing. So I had done most of the stuff to this time. I didn't refer back to any of my old code, but hopefully this is going to be relatively blind, but hopefully we'll get to work on this as well. We'll get it to work on this. Again, we'll load this stuff up. We've got all the action figures, hopefully. G.I. Joe. We'll call it G.I. Joe URL. Okay, so what we want, I didn't get much instructions, but I'm just going to assume what you want is the list of URLs that these things make up, essentially. So all of these G.I. Joes, will try to get all of the URLs that this makes up. So again, I'll start with inspect. Kind of look at what's happening here. Okay, so you've got a bunch of A references, which will give you the link to the. So this gives you a link, and I think instead of a text thing, it has an image. So there's no text on this page. All you do is you click this, and it takes you to the biography of this G.I. Joe figure. And it has a whole bunch of stuff about these things, but apparently this was... Okay, well, there's probably problems here, so let's look at what... Let's kind of look at the naive approach, and then we'll kind of get fancy as we need to. So you got this main container. Okay, so basically I like to just kind of hover over the stuff. You can see it kind of flashing as to what exactly is happening and what you're looking at. So left content, that looks good. We'll drill down as much as possible so we don't get extraneous stuff. So we've got, this is the list of years. This may be relevant. We may need to access this later. You got this class called corners. You got float R links. You got a bunch of clear classes. I think this is to like clear the class itself, or is it like a transparent divider? Unsure. Okay. And then a bunch of A classes. So let's take this corners class. G.I. Joe URL. I'm gonna call it GI page because it's too much typing. Okay, so page loads stuff, and then HTML element. What did I just call it? Corners. So this is again referring to the class dot corners. Still got stuff. And then we want the A references with an href in it. So we'll take all the HTML elements this time, and we'll take all the ones that have A 0. Okay. So there's no A elements, so there's no anchor elements inside of corners. So what we can do is print out GI page. So if you just try to type GI page normally, what it's going to do is give you like a kind of an overview of what's inside of it, but you can't really like get to what's going on here. So what we can do is run something like as character GI page, and then it will convert it to raw HTML. This may cause my computer to freak. Nope. Okay, there's literally nothing in here. So you got corners, contents. I was pretty sure it was corners. Okay, so hang on. So I see a bunch of stuff here. I want... This looks like the images. And it looks like it's at the bottom? So there's a second corners thing with float years. There's a bunch of... There's an ungodly amount of tabs and new lines and stuff. And the first thing... So this is probably the first thing. This is what you would expect to get. This is... Top nav content small. Okay. And then this corners thing doesn't have an ID, but we want the... Is it float years? This looks like the whole page almost. What is going on here? Okay, so instead of looking at it here, one of the things you can do is inspect and go to the network page like we did before, and we'll press Control F5. If you press F5 like the regular way, what it's going to do is it will load, and it will, because your browser caches stuff, if you press Control F5, in this case for Firefox on Windows, it will like bypass the cache and it'll actually remake the request again. So you got a bunch, so it is loading all these images separately. There's a bunch of JavaScript, CSS, and then there's this action page. So this is what you would get. So this GET request on this action gives you literally what rvest would get. So if you go to the response here, you can kind of see what's included. So it looks like it's loading these, but only these carded. So it should be able to get this. So I've switched to raw, which is literally the HTML, rather than just rendering the base action page. And okay, so we got, well, these look like header things. So there's G.I. Joe database, you got toys. I think that refers to this set of headers here. So we're gonna skip past this. So this is a top nav. With this one, you can't actually like load it there. So so with this, you can't actually hover through it. Wait. I just thought of something. I left HTML elements here, but I didn't go through HTML elements A on all of this. Okay, so maybe I was overcomplicating this. Eric, welcome to the stream. How you doing? Okay, I am vastly overcomplicating this. So I was looking at the wrong corners element before, but we should be able to see all of these links here, and we should be able to get to these. So we should get a list of all these characters, at least. GI page, so let's put in a GI page. How do I view you the best? GI page. Could you target CSS selectors? Yes, I have been. These are CSS selectors. This is a CSS selector for the class corners. This is the CSS selector just for the element, like the tag. And we were earlier using better CSS, not better, more complex CSS selectors for I still Why don't I have this bookmarked? I don't know. I just like taking the long way, apparently. But you can use any of these selectors. We were using this href starts with HV selector earlier. Okay, so it looks like this page returns the very first one, but we could check the network to see how we should check this. So we get 83, 84, 85. Okay, so you pass in the last 2 digits and you get a whole bunch of pages for these. Okay, so to get all of these, so basically what we're going to try to do is get the image link and the so I think a tidy data frame of G.I. Joe figures would have the image link, the name, because I think there are names, right? There are names, so each one should have a name. So the title element is the name. We want the link to them, and also a link to the picture for each one. So all in all, this should be doable. Yeah, I don't think it's too hard. Okay, so for each page, and the very first page takes you just to this page, I think. So we'll just start there. And we'll do this branching thing where we take the first ones, and figure out how to get to these links. So float our links is not what we want. We want this ahref group. I don't see a list of titles, but we were able to drill down to the corners group. Okay, so we must have been looking at this corners, but we don't want the ones with the class float years. Do we want the ones with the class float years? Don't think so. Okay, so from here we'll try to grab all the hrefs, and actually wait, is there a selector that gets rid of stuff? I think it's not equal to. Ends with could be useful. I think I noticed that they were all SHTML. Hang on, so the corners links gives us all these pages, and I think they don't have SHTML. So we want the ones that end, all the links with href ending with SHTML. So what we're going to do is href, I think this was, what's the end one? Ends with, so that's a $sign. Okay, so that refers to, I think it's the same as regex. That's actually news to me. We're gonna do $$ equals HTML bracket. And so there's 16. Are there 16 here? I may need to count. There's 8 here, 11, 5 is 16. Okay, good. So this gives us all of the elements that are here. So ideally, we can form a tibble with name, URL, image, and URL. Yeah. So name, image, URL. Name's going to be equal to GI page, HTML element, Actually, no. We'll go HTML attribute title. Yep, all the titles. We'll do equals GI page HTML element image. Okay, and then we want the, I think the source. Yep, so the SRC. So we want the SRC source element. So this is the HTML attribute source URL GI page HTML attribute href. Okay, so we've got a data frame now. Okay, so that's one of them, but we want to get through all of these. So what we can do is try to go through all of these float years, perhaps? I call it float years because that's what it's called in the HTML. But basically what we want to try to do is get to all of these, yeah, we do want to, yeah, if you're cleaning this afterwards, you would want to glue it with the base website URL. That's what the syntax here is for. This images thing, you would glue with www.yojo.com/images, blah, blah, blah. I am looking to grab, so first I'm going to grab, I jumped from, okay, so we did this first page. What I want to do is grab all these pages. So instead of grabbing, I want to try to loop over all of these pages to get all these, to get this table for every one of the pages first, and then from there, you know, we can clean up and add the base URL onto this image. That would be that's a great point. You can't actually use it like that, but you can you can get there after you do the whole data frame. So I'm going to try to build that loop first, and then we'll get to the next thing. Tibble. I mean, there's a. Wonder if there's a function to specify the URLs. Probably is, but don't know it offhand. Alright. We'll get there, and then we can manually attach the URL, the base URL part. So if we knew this offhand, we could glue these together ourselves. Wait a second. Oh. How do I get that? That would be easier, wouldn't it? Would it be easier? What are you? Alphabetical. What are you? How do I get you? So there's JavaScript here that happens. Create scraping functions and purr away. Yeah, I mean that's... Hang on. What are you? Okay, so this brings me to the... I will... yeah, so I would scrape... So I would totally make a function for this first. For pedagogical reasons, I would start with getting a list of all the years that are possible, and then wrap this part into a function, and then loop over it. So I use map to like map over every list, every one of the URLs. There may be. Okay, so back to the so your instincts are absolutely right. It's very much what I would do as well. I am distracted by this alphabetical listing because it would be easier to scrape all in one page if it's there. So one of the tricks, one of the like experience tricks that I like using is sometimes there are pages with JSON or like other hidden elements, and one of the secrets about those is that they'll return a whole bunch of stuff. So you see all this white space, you might not see this, hang on. You see all this white space here, so you got like the main HTML kind of fits pretty vertically, right? Like it's rare that it's like minimized, so it's usually like printed like this vertically, so you got all your rows, blah blah blah. And it's really hard to find specific things, but one of the things that I've noticed, and this is kind of like personal usage more than anything else, is what you can do is kind of broaden this a bit and then scroll to the end and I'm here, but the idea is if you scroll wider, there's usually more interesting stuff if it extends horizontally. So if they dump you a whole bunch of JSON in that page, Fantasy Pros is sometimes guilty of doing this, if you scroll a little bit like out to the right here and then like scroll down, if you see things, so that's my current selector, but if you scroll down and you see a text line go by, this is usually really interesting. It's either that or it's like all of jQuery, but sometimes it's really interesting. So like this has that list element of all this stuff, and if I can get to this, that'll be a lot easier to scrape. Alphabetical list. Okay, this looks useful. Let's go after this. We'll kind of digress. We'll call this GI alpha for alphabetical lists. We'll start with GI URL, pipe HTML, or read HTML first, and then pipe that to HTML elements, and what's this called? Is ID alphabetical list. So it's an ID, so you start with the hashtag alphabetical. How is it spelled? Little L, big L. Okay, so camel case, I think. Okay, so you got a list of one, so we can just get that. And then from here, give me all of the list, all of the A elements. HTML A, HTML element A, and then from here, GI table would be tibble, GI name equals the text from this HTML, so HTML text GI alpha. URL would be HTML attribute GI alpha href. Okay, 92. Only starts with A, so it's not that much better than the previous way. Is it? Okay, so this is not much better, but it's worth digressing because sometimes they'll give you all the data. Is there any case where you'd say, nope, I definitely need Selenium? Yes, I have come across one. If you're familiar with soccer, I've tried scraping Who Scored, and they do checks, some kind of checks that I haven't managed to get around with just rvest yet. I've tried. I tried a little bit on someone's favor, but soccer isn't normally my sport. I haven't really tried forcing it. Hang on, what's this? So you got alphabetical listing, you got void. You switch alphabet, you get this. Is there more? Nope. Does it go to a different page? What did you just do? Did you do something? Load alpha template. Another post request. Okay, so this one sent a bunch of cookies. And then you can pass a bunch of letters. And then you get this response. So theoretically, you could also go the other route of posting to this thing, getting this list back, and then parsing this list instead. I don't know if that's much better. It's pretty similar. It's pretty similar to looping over by year. Some amount of work. The other way gets you images, and there's, 1982 to 2018. I don't think there's all, so it's about the same amount of work to scrape them. Any preferences, anybody? You want to see year? Do you want to see it by alphabetical? They're about equally painful in my approach. Well, I say painful. Fun in my approach. So I will defer to chat here if you guys want to see another post thing or another just loop over a bunch of pages again. Crickets? Indeed. I don't have a preference, so let's just go with the previous stuff because I think it's a little easier to set up. Diverging opinions by year and alphabetical. So kind of looking at this. So again, I think by year would be repeating kind of what we did with HTTRS, where you kind of set up a function. TFRRS, the track one, where you set up a function and then you loop over by year. So as long as you're happy with the output of the first year, you can continue through the rest of the years relatively easily. So kind of looping through the float years. So let's get the float years. We'll talk about that. Maybe we'll try both approaches and see if we can get through both. Presuming that there isn't another thing that people want me to look at. I have a gist of... This is the gist that I'm looking at here. If you have stuff, feel free to just drop a link in the comments and I can get to it. But if I finish this first way, and then I'll finish the year looping, and then if there's nothing else, we'll go back and do the post method as well. Just kind of give a second view of that. So okay, so we'll leave that for a second. Okay, so getting a year of the float. So there's a couple ways. GIF, GIF. I go back and forth. I don't know. It starts with a G. Okay. So the cheaty way, but it gets the job done way, would be to look at this, say, okay, so there's, it looks like it just takes the last two digits of the year. It takes the last two digits of this year and then uses it. So 2018 is 18. So basically you just create an element. The cheaty way would be 1982 to 2018 and string sub start 3 and 4. And that gives you a bunch of GI float years, 82, 83, 84, blah, blah, blah. And there's also this international one, which is called TE, but it doesn't have the same pattern, so we'll leave that alone for a minute. So, okay, so we got 37 observations, or 37 years. Move that around so I don't get that. Okay, so basically then wrap this in a function. Year stub is going to be equal to, pop that down there, indent. Okay, so the URL is going to be this paste 0 with a year stub. Read this GI URL, get these things. This is outside of that, and then return GI table. Wait, I didn't name it. Scrape GI. Here. Hey, Tony took me up on it. Nice. Okay, I will look at Tony's thing very shortly here. There, and then to get the GI tables, we can get, we'll do map DFR, GI float years. Basically, so we're going to map over this function, then bind these columns back together, scrape GI, and it just work. So while that's working, oh, 404'd. So I'm going to use options error equals recover here, and see what happened. Okay, that looks fun. We'll look at it. And so we're just going to jump into the debugger, try to get into here. So I selected, so usually you don't want to select, so I ran the debugger, so I put options equals recover. This is going to be a mini debugging lesson. And what I did here was read HTML is probably the function that failed. That's the one that I wrote. So what I want to do is get into the one above that. So I typed 3, and that'll give me access to calling this GI page. So we're looking at GI URL 95. Okay, so 95 doesn't exist. Okay. So what we can do is use pers possibly try 95. If it fails, do something else. So that's probably the best way to do that. So we will so instead of scrape GI by itself, we'll change it. This possibly is called a function operator, and basically what it does, it's a function. Sorry, I say function operator because that's what I learned in advanced R. It's actually a function decorator in normal people language. I made a pull request, but I still think of it as an operator. And we'll do possibly that. Otherwise, return a tibble. And so basically, do this. If it doesn't work, return a blank tibble. And then when you bind rows, the empty tibble will just evaporate, hopefully. So that makes the possibly, and then that makes that. Closing unused connections. Okay, not bad. Alright, so now we've got a list of all of the stuff. I neglected to include the year itself here, which I could have. I would just change how the mapping is done. So instead of doing it that way, I would have done 1982, 2018. We'll mutate this index, so ID is going to be equal to string sub years 3, 4, and then we'll map here. So the data is going to be map ID, possibly scrape GI, otherwise Tibble. And then we'll need to unnest the data because we ran it as a list. So temp number 2, we'll do something very similar, but instead of like just mapping DFR, what we're going to do is bring in a year column as well, and that'll give us a little bit more data than what we had before. Cross our fingers. Okay, so instead of version 1, which we just bind rows on the result, what we're going to do, what we did here was this one, also kept the year itself. And then from here, like Platinum G&G suggested earlier, you'll still need to clean up this image because it's a relative URL, so you'll need to paste Yojo on it and then continue on it from there. But I like to just do as minimum as possible within the loop because it goes a little faster, and then I like doing like that kind of post-processing afterwards. It's personal preference. Like that post-processing also takes time, so it doesn't matter really, but that's just how I like to think about it. And you know, that's that. Possibly your mind. Yeah, I mean it possibly could. Okay, so Tony submits this. We've got 20 odd minutes before somebody else in data science Twitter streams. Pretty sure. Who else is live? Oh my gosh, a whole bunch of people are live. Okay, so yeah, so we'll stream for another. We'll have a quick look at Tony's VAR decisions. Tony, you still here? What do you want from this? Like, there's a whole bunch of stuff here. What do you want from it? Oh, you just want to see like what data do you want? Get it all. Like the text? Like, do you want this into a table? Like, what are we talking about here? What is it? Or maybe just review your code. Yeah, we'll do that instead. I don't know what you want. Hello, we've got 200 and... Oh, the bullet points. So, like, this one. Okay. So this is Tony. So Tony is absolutely, like, a very extremely accomplished scraper in himself. Like, I have 100% confidence that this will work perfectly. Do scrape. Season. Overwrite is false. Dear 30 var. So dear 30 var. So I'm assuming that's it's gonna dump into a directory on scrape. File path. File path, this makes a path, and then var by team, var by, so he's setting up a bunch of places for the data to live. We got a bunch of URLs, one for 2020, one for 2019. Okay, so these are, so you can't really loop over these because ESPN publishes their data in articles, so it's not like there's a consistently updated source of data. So that's what's happening here. You got this URL, and then there's another URL for 2019, and then if they choose to publish another one, it'll be somewhere else for 2021. The hope is that the format will be consistent. It may not be. Okay, so then you got URL, read HTML. So read HTML, take all the H2 nodes separately. So H2 nodes meaning these nodes separately, and hoping that they keep consistent to only using H2 for the player, like for the team themselves. Teams will be HTML text of H2, taking the first 20 and string removing it. Yeah, I think that, I mean, if it's, I don't know if there's anything more fancy you can do with the text. Because this is an article, so it's not like a table. Tables will tend to have embedded information. Articles like this will just be exactly what they say on the tin, which is, it's more likely to just be text. It's less likely to have attributes. Like here, you've got strong, and then the result. And then you got another strong, and then another result. Strong, another result. Strong, another result, blah, blah, blah. So it's less likely that you're going to have something, if that makes sense. You're looking for things that might improve. Yeah. Kind of narrating my understanding process here. So you got strong. So like exactly what I was just saying, strong. Then you got nodes, the paragraph nodes, and you made it into text. Looking for things that start with overturns. So using overturns, the first which ones that are overturns means that you're going to use this as the separator between teams. Yeah, I think that makes sense. And then nodes filt. You're going to take nodes P, and then you're going to take those ones. Preserve non-breaking spaces equals true, and string split on n. So basically, read each section. So read each of these as its own section, and then split by line. That's pretty efficient. You name this function f. That's hilarious. Possibly wasn't really working since you want stuff like integer. Possibly wasn't really working because as I wanted, since stuff like integer 0 is being returned. Okay, so you're taking the regex. So you're kind of setting up like your own regex scraper to do that. This is where, so especially with this one, kind of something I would do, kind of like this is almost like the very first example where I did the mines, and pretty consistently it looks like these are colon separated. So what I would probably lean to doing is separating names and values, filtering the name. So you're getting to the exact same point as me, which you got to the same point. I would my code would look different because I don't do it like this, but this ideas are very the same. From here, I wouldn't parse each one separately as much as I would just slap this all into a table, separate on colon, so game, incident would all kind of go into its own thing. Net subjective score, like all of those things would separate. Then you would filter game and incident out of that and parse those separately, and then that would have a whole bunch of text with that like colon separated wider. And then these ones could be formatted into ints. So you look at these, separate them, format to int, all in one go. And then you'd have like a table of stats for each team, and then game. That's how I would do it. There's nothing saying, like, I don't know if that's faster than your way. I suspect it would be faster just because you're looping over all this stuff, looking for things each time, as opposed to building one whole table large and then parsing through it, separating, doing the separator on the colon because everything separates on colon, and then filtering through by the name separator, like the separated name, and then doing two different parsing treatments for those. That's what I would suggest you do something similar here for penalties. Okay. Yeah, so I think it's the same idea, but I think like yours is very similar. I would be wary of doing so many maps if I could do separate, because I think my intuition is that this is slower, but usually not by much. Yeah. What you could do is do a cumulative sum that each one is equal to, like, try to generate an index for each of these elements. Wait, what happens here? So you have a list of teams, bind calls, egg. Matching up the teams with the tibble at this point. There's a lot of stuff that goes on in this table. Yeah, I mean, you could try some kind of mapping or nesting out of the whole separate function, but on the whole, I think, you know, it's very similar to what I would do. My minor tweak would be doing separate, like making one big table, separating it, and then cleaning it, but it's very similar. Okay. Get the link to this in the chat. To the scrape this is the page that I've been working through, including the ESPN and Tony solution here. Yeah, it's hard. I mean, I think scraping is easiest when it's a table, right? Like when someone prevents you a table, it goes to a like it gives you a lot more of, like, if you want a data frame out of it, go from there. We got really lucky, like really lucky to be honest, with this this mines thing, because it's almost a table. It's an accordion, but all the elements were the same, so it makes it a lot easier to bring into R as a data frame, which is what you want to work with it. But when it's like an article and it's laid out like this, it's kind of annoying actually. So I totally agree. It's not impossible. Like obviously it's actually there, right? So the text is printed to you, so you're not writing post requests or doing some other fun stuff like that. Yeah. Also an article. Again, articles are the primary way that data is distributed in soccer apparently, and actually it's probably the primary way ESPN distributes stuff. But even like Tom Mock's like FPI scraping also like scrapes the table, and that makes it a lot easier. Sometimes, you know, when you're doing it out like this, it's hard. But yeah, so feel free. Tony commented his thing right here, and I want to call it a stream. I know some people are currently watching. We can go to Tidy. So today is Monday, but we do Tidy Tuesday stuff. So that's it for the office hours. I will try to proverbially bind rows all these videos together, and I will send you guys to either Nick or Alyssa. Stick with the R streamer. Yeah, we'll send you to Alyssa. Thanks for coming in, everybody. Hope this was useful. I will record this. You can check out the VODs very shortly, and kind of rewatch. I will commit all this to an office hours repo and put it on my Twitter. Okay, everybody. We are going to raid Alyssa. Thanks for coming in, and we'll see you all. I stream on Saturdays and Sundays. We'll see you then.
Related to baking, but also related to baking, I have a cheese kit coming, and I am so hyped about it.